Hello everyone, welcome to my YouTube channel. Hope you all are doing extremely well. So today in this video we'll be solving December Leetcode challenge. The problem is convert binary number in a linked list to integer. So let me tell you the approach that we're gonna follow. So first of all we'll be understanding the problem statement, then the logic part, and then we'll be coding it up, right? So let's understand the problem statement first. But before proceeding further in the video, if you are new to this channel or if you haven't subscribed our channel till now, then please make sure to subscribe our channel. So here you can see given hat, which is a reference node to a single linked list. The value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. You have to tell or you have to return the decimal value of the number in the linked list. For example, let's understand with this one. So this is the linked list given to us consisting of 1, 0 and 1, right? So if you will convert this binary representation to decimal, your output will be 5. Let's understand how. So you know that we start from here. So 1 into 2 to the power 0, you will be having 1, plus 0 into 2 to the power 1, you will be having 0 itself, then plus 1 into 2 to the power 2, you will be having 4. So 4 plus 0 plus 1, you will be getting 5, and that's what we are getting in the output. Here example 2, you can see had a 0, so the output will be 0. For this one, the output will be 1, right? So what I'm expecting from most of you, like, you must be knowing that how we can, it's just a simple problem that how we do convert binary to decimal, right? So you all must be aware of that. But let's understand that how in case of linked list we'll be doing so. So let's suppose this is our linked list consisting of these elements. Let me just make it. So if it is like giving you a binary representation, so how you're gonna do this? Let me quickly write this as well, although I explained. So 0, 1, 2. So from here you'll be getting 1, from here 0, from here 1, you'll be getting 5, right? So but here in this case, can we do like this, right? Because if let's suppose if you move to this last one, then we cannot come back to 0 and then 1. One approach can be, one thing that we can do is just simply, one thing that can be in your mind is just reverse the linked list. For example, if let's suppose your 110, this is the elements in your linked list. So it's not like you have come to here, then this one, 2 to the power 0 you will take here, 2 to the power 1 you will take here, 2 to the power 2 you will take here. So you won't be able to come back, right? Because it's just a linked list is moving in one direction. One thing you can do is just reverse the linked list. If you are just reversing your linked list, so that's a possibility. So from here you know that it is 2 to the power 0, 2 to the power 1, 2 to the power 2, and it's like simple thing, 2 to the power 0 into 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2, right? So this is the one thing that you can do, but again it's sort of complex, right? We don't have to do that much complex thing to reversing and all in that case. Other thing that you can do, or probably that should be in your mind, is what we can do is just count the length of this linked list. Count the length. Okay, it is 110 now, so count the length of this linked list. So what is the length? 1 2 3, you know that. So it's just simply subtract just 1 from the length of the linked list, and from here you can take 2 to the power 2, 2 to the power 1 and 2 to the power 0. So one by one we are just reducing that power thing. So this is also one thing you can do, right? You must be getting the idea. But even then there's an efficient solution exists. So let's understand the efficient one, right? Now the efficient one is based on a faith. What kind of faith? Okay, let's suppose these are the elements 1 1 0. So we are having a faith that this is our last element. This is our faith that we are currently on our last element. So if it is a last element, what power you have to consider? 2 to the power 0, or we can simply say 1. All right. So we can take a variable to which, if you know that, if you are simply doing 2 to the power 0 into 1, this is nothing but 1 itself. So 1 into 1, if you are going to do, you will be simply getting that particular value itself. So initially the head value, whatever it is, we are simply adding to our sum value. But when you will proceed further, you will come to know that okay, this wasn't the last element, because still there is one element that exists. So what you will be doing is you'll be updating your sum or result variable by multiplying 2 to it. So now the sum value is going to be what? The previous value was 1, right? Sum value was 1. 1 into 2, it will be 2 now. Now we are having a faith that now the element on which we are, that is our last element. Okay. Now we are on last element. So we'll be simply adding the value of this one, this particular node to our sum. So we'll be having 3. But again, when you will proceed further, you come to know, okay, no, this wasn't the last element. If still there is one element that exists. So you will be simply multiplying the value of your sum with 2 and you will be having 6. And now you will be, sum value will be updated to 6. Now, again, we'll be having the same faith that the element on which we are currently, that is our last element. You'll be adding the value of this particular node, that is 0, to your sum. So you'll be having the output as 6 itself. And this time, yes, it was our last element, because you can see now there is no such element for the element that exists, and head value will be what? It will be null now. So 6 is the correct answer for this particular binary representation 110. So this is the approach that we're going to use. We are just going to code it up. So I hope that is clear for you. So let's move to the code part now. So you can see this is our code. We have simply taken a variable, sum initialized with 0, and now we are taking a list node. So that is basically pointing to what head is pointing to, and we are simply taking a loop and continuing in this loop till the time temp value is not equal to null. So the multiplication will happen only if your fifth is breaking. What is your fifth? That you are currently on your last element. And if it is not so, you will be multiplying your result or your sum variable with that of 2, right? And we are simply adding the value of the current node on which we are to our sum, and we are keep on updating the value of temp as well by doing temp equal to temp dot next, and at the last we are simply returning sum, right? So I hope the solution is pretty much clear for you. Even I have provided the code in the description, so you can just check it from there for your reference. So thank you so much for watching this video, guys. Keep learning, keep preparing, keep coding. Bye bye.